Artificial intelligence is transforming the way computers interact with the world. At its core, AI enables machines to learn from data and make decisions, often without explicit programming. Two major fields within AI are machine learning and deep learning. Understanding the differences between these fields is crucial for anyone interested in technology, data science, or the future of automation. In this video, we'll explore what sets machine learning and deep learning apart, how they work, and why they matter in today's digital landscape. Let's begin by defining these concepts and their roles in artificial intelligence. Machine learning is a broad field within artificial intelligence. It focuses on creating algorithms that can learn patterns from data and improve their performance over time. These algorithms don't require explicit instructions for every task. Instead, they use statistical techniques to find relationships in data. Machine learning models often need human guidance to select relevant features and structure the data appropriately. This approach is widely used in applications such as spam detection, recommendation systems, and basic image recognition. Let's look at how machine learning operates and why it's foundational to AI. Key aspect of machine learning is feature selection. This means identifying which pieces of data are most important for the model to learn from. Human experts often guide this process, deciding what information should be included and how it should be structured. The quality of feature selection can greatly impact the accuracy and effectiveness of a machine learning model. By carefully choosing features, models can better recognize patterns and make reliable predictions. This step is crucial in applications like email filtering, where the right features help distinguish spam from legitimate messages. Machine learning is used in many everyday applications. For example, spam email detection relies on ML algorithms to identify unwanted messages. Recommendation systems such as those on streaming platforms use ML to suggest content based on user preferences. Basic image recognition, like identifying objects in photos, also uses machine learning techniques. These applications demonstrate how ML models can handle structured and relatively simple tasks, making them a vital part of modern technology. Their ability to learn and adapt over time keeps them relevant in a rapidly changing digital world. Deep learning is a specialized subset of machine learning. It uses artificial neural networks inspired by the structure of the human brain. These networks consist of multiple layers, allowing them to learn complex features from raw data. Deep learning models require less human intervention for feature selection, as they can automatically extract relevant information. This makes them powerful for tasks that involve large amounts of data and intricate patterns. Deep learning is behind many advances in AI, including speech recognition, natural language processing, and advanced image analysis. Artificial neural networks are the backbone of deep learning. These networks are composed of interconnected nodes, or neurons, arranged in layers. Each layer processes information and passes it to the next, enabling the model to learn increasingly complex features. The depth of these networks allows them to handle tasks that traditional machine learning models struggle with. Neural networks are particularly effective for analyzing unstructured data, such as images, audio, and text. Their ability to learn from raw data without manual feature selection sets deep learning apart from other AI approaches. One major difference between machine learning and deep learning is the amount of data required. Deep learning models typically need vast amounts of data to perform well. This is because their complex neural networks learn intricate patterns and features, which requires extensive training. In contrast, machine learning can often work effectively with smaller datasets. The need for large datasets in deep learning has driven advancements in data collection and storage, making it possible to tackle more challenging problems. This data dependency is a key factor in the success of deep learning applications. Performance is another area where machine learning and deep learning differ. Machine learning models excel at simpler structured problems. They are reliable for tasks like classification and regression, where the data is well organized. Deep learning, on the other hand, shines in complex tasks such as speech recognition, natural language processing, and advanced image analysis. Its layered neural networks can uncover subtle patterns and relationships that traditional ML models might miss. This difference in performance makes each approach suitable for specific types of challenges. Deep learning has revolutionized speech recognition. By using neural networks with many layers, DL models can analyze audio signals and understand spoken language. This technology powers virtual assistants, voice-controlled devices, and automated transcription services. The ability to process and interpret complex audio data sets deep learning apart from traditional machine learning, which may struggle with such tasks. As a result, speech recognition systems have become more accurate and responsive, improving user experiences across various platforms. Natural language processing (NLP) is another area where deep learning excels. NLP involves teaching computers to understand and generate human language. Deep learning models can analyze text, extract meaning, and even generate responses in real time. This technology is used in chatbots, translation services, and sentiment analysis tools. The complexity of language makes NLP a challenging task, but deep learning's layered approach allows it to capture nuances and context that simpler models might miss. As a result, NLP applications have become more sophisticated and effective. Deep learning is also behind advances in image analysis. Its neural networks can automatically detect objects, recognize faces, and classify images with high accuracy. This technology is used in medical imaging, security systems, and social media platforms. By learning from vast amounts of visual data, deep learning models can identify subtle features and patterns that are difficult for traditional machine learning to spot. The result is more reliable and sophisticated image recognition, enabling new possibilities in healthcare, safety, and entertainment. Computing power required for machine learning and deep learning differs significantly. Machine learning models can often run on standard computers, making them accessible for many users. Deep learning, however, usually needs powerful hardware like GPUs to process large datasets and complex neural networks. This requirement has led to the development of specialized hardware and cloud-based solutions. The increased computing power enables deep learning models to tackle more challenging tasks, but it also raises the cost and complexity of implementation. Graphics processing units, GPUs, are essential for deep learning. These specialized chips can handle the massive computations required by neural networks. GPUs accelerate training and inference, making it possible to process large datasets efficiently. As deep learning applications grow, the demand for powerful GPUs continues to rise. This hardware is now a standard part of AI research and development, enabling breakthroughs in fields like computer vision, speech recognition, and natural language processing. Cloud-based solutions have made deep learning more accessible. By providing powerful computing resources online, cloud platforms allow users to train and deploy DL models without investing in expensive hardware. This flexibility has accelerated innovation in AI, enabling startups and researchers to experiment with complex models. Cloud services also offer scalability, making it easier to handle large datasets and demanding tasks. As a result, deep learning is now within reach for a wider range of organizations and individuals. Interpretability is a major advantage of machine learning. ML models are generally easier to understand and explain, making it possible to trace how decisions are made. This transparency is important in fields like finance, healthcare, and law, where accountability is crucial. By understanding the logic behind predictions, users can trust and validate the results. Interpretability also helps identify potential biases and errors, improving the reliability of ML systems. Deep learning models are often described as black boxes. Their decision-making process is complex and difficult to interpret. While DL models achieve high accuracy, it's challenging to explain how they arrive at specific predictions. This lack of transparency can be a concern in sensitive applications, such as medical diagnosis or financial forecasting. Researchers are working on methods to improve interpretability, but the layered structure of neural networks makes this a tough challenge. Machine learning is widely used in finance. ML models help detect fraud, assess credit risk, and automate trading strategies. Their interpretability allows financial professionals to understand and justify decisions, which is essential for regulatory compliance. By analyzing historical data, ML systems can identify patterns and predict market trends. This makes them valuable tools for banks, investment firms, and insurance companies. Deep learning is making waves in healthcare. DL models analyze medical images, predict patient outcomes, and assist in diagnosis. Their ability to learn from vast amounts of data enables them to spot subtle patterns that human experts might miss. However, the black box nature of DL can be a challenge when transparency is needed. Despite this, deep learning continues to drive innovation in medical research and patient care. Recommendation systems are a classic use case for machine learning. ML algorithms analyze user behavior and preferences to suggest products, movies, or music. By learning from past interactions, these systems personalize experiences and increase engagement. The interpretability of ML models helps developers understand why certain recommendations are made, allowing for continuous improvement and user trust. Deep learning has transformed image recognition. DL models can identify objects, faces, and scenes in photos with remarkable accuracy. This technology powers features like automatic tagging, facial recognition, and visual search. By processing raw image data through multiple neural network layers, DL systems learn to detect even the most subtle features. This capability is essential for applications in security, social media, and healthcare. Machine learning is crucial for email filtering. ML models analyze email content and sender information to distinguish spam from legitimate messages. By learning from labeled examples, these systems adapt to new spam tactics and improve over time. The transparency of ML models allows administrators to understand and refine filtering rules, ensuring reliable communication. Virtual assistants rely heavily on deep learning. DL models process voice commands, understand context, and generate responses. This technology enables assistants to handle complex tasks, such as scheduling, searching, and controlling smart devices. The ability to learn from vast amounts of conversational data makes DL ideal for creating responsive and intelligent virtual assistants. Retail businesses use machine learning to optimize operations. ML models forecast demand, manage inventory, and personalize marketing. By analyzing sales data and customer behavior, these systems help retailers make informed decisions. The interpretability of ML models allows managers to understand the factors driving recommendations and predictions, improving business outcomes. Deep learning is at the heart of autonomous vehicles. DL models process sensor data, recognize objects, and make driving decisions in real time. By learning from millions of driving scenarios, these systems improve safety and reliability. The complexity of driving environments makes DL essential for handling unexpected situations and ensuring smooth operation. Marketing teams leverage machine learning to target audiences and optimize campaigns. ML models analyze customer data, segment markets, and predict buying behavior. The transparency of ML algorithms helps marketers understand which factors influence campaign success, enabling data-driven strategies and better ROI. Entertainment platforms use deep learning to enhance user experiences. DL models recommend movies, generate music, and create personalized playlists. By analyzing vast amounts of user data, these systems learn preferences and deliver tailored content. The complexity of entertainment choices makes DL ideal for capturing subtle tastes and trends. Security systems rely on machine learning to detect threats and prevent breaches. ML models analyze network traffic, identify suspicious activity, and alert administrators. The interpretability of ML models helps security professionals understand the logic behind alerts, enabling quick response and improved protection. Robotics is another field benefiting from deep learning. DL models enable robots to perceive their environment, recognize objects, and make decisions. By processing sensor data through neural networks, robots can adapt to new situations and perform complex tasks. This flexibility is essential for applications in manufacturing, healthcare, and exploration. Education is being transformed by machine learning. ML models personalize learning, recommend resources, and assess student progress. By analyzing performance data, these systems help educators tailor instruction and improve outcomes. The interpretability of ML models ensures transparency in grading and feedback, building trust among students and teachers. Gaming companies use deep learning to create smarter and more engaging experiences. DL models generate realistic environments, adapt gameplay, and personalize challenges. By learning from player data, these systems deliver dynamic content and keep games fresh. The complexity of modern games makes DL a valuable tool for innovation and creativity. Logistics companies use machine learning to optimize routes, manage shipments, and predict delivery times. ML models analyze traffic patterns, weather conditions, and historical data to improve efficiency. The interpretability of ML models allows managers to understand and adjust logistics strategies, reducing costs and enhancing service. Social media platforms use deep learning to analyze content, detect trends, and moderate discussions. DL models process images, videos, and text to understand user behavior and preferences. By learning from vast amounts of data, these systems deliver personalized feeds and improve user engagement. The complexity of social interactions makes DL ideal for capturing subtle signals and patterns. Manufacturing relies on machine learning to monitor production, predict maintenance needs, and optimize processes. ML models analyze sensor data and historical records to identify inefficiencies and prevent breakdowns. The interpretability of ML models helps engineers understand the factors affecting performance, leading to better decision-making and increased productivity. Deep learning is inspiring creativity in art and design. DL models generate original artwork, assist in graphic design, and enhance photos. By learning from vast collections of images, these systems can mimic styles and create unique pieces. The complexity of artistic expression makes DL a powerful tool for artists and designers seeking new ways to innovate. Agriculture is benefiting from machine learning. ML models predict crop yields, monitor soil health, and optimize irrigation. By analyzing environmental data, these systems help farmers make informed decisions and improve productivity. The interpretability of ML models ensures transparency and recommendations, supporting sustainable farming practices. Exploration missions use deep learning to analyze data from space, oceans, and remote environments. DL models process sensor readings, images, and signals to discover new insights. By learning from complex and unstructured data, these systems help scientists make breakthroughs in understanding our world and beyond. Customer service is enhanced by machine learning. ML models analyze inquiries, route tickets, and suggest solutions. By learning from past interactions, these systems improve response times and customer satisfaction. The interpretability of ML models allows managers to understand service trends and refine support strategies. Deep learning is advancing forecasting in weather, finance, and supply chains. DL models analyze vast datasets to predict trends and outcomes. By learning from historical and real-time data, these systems deliver accurate forecasts and help organizations plan for the future. The complexity of forecasting tasks makes DL a valuable asset in decision-making. Insurance companies use machine learning to assess risk, detect fraud, and personalize policies. ML models analyze customer data and claims history to make informed decisions. The interpretability of ML models ensures transparency in pricing and coverage, building trust with clients and regulators. Deep learning is improving fraud detection in banking and e-commerce. DL models analyze transaction patterns, identify anomalies, and flag suspicious activity. By learning from large datasets, these systems adapt to new fraud tactics and enhance security. The complexity of financial transactions makes DL ideal for protecting assets and customers. Supply chain management is optimized by machine learning. ML models forecast demand, track inventory, and manage logistics. By analyzing historical and real-time data, these systems improve efficiency and reduce costs. The interpretability of ML models helps managers understand supply chain dynamics and make informed decisions. Language translation has been transformed by deep learning. DL models analyze text, learn grammar and context, and generate accurate translations. By processing vast amounts of multilingual data, these systems deliver real-time translation services and bridge communication gaps. The complexity of language makes DL ideal for capturing nuances and delivering high-quality translations. Personalization is powered by machine learning. ML models analyze user preferences, behavior, and feedback to tailor products and services. By learning from individual data, these systems deliver customized experiences and increase satisfaction. The interpretability of ML models helps businesses understand the factors driving personalization, enabling continuous improvement. Deep learning is advancing analytics in business, science, and technology. DL models process complex datasets, uncover hidden patterns, and generate actionable insights. By learning from diverse sources, these systems help organizations make data-driven decisions and innovate faster. The depth of DL models enables them to tackle challenges that traditional analytics cannot. Summary: machine learning and deep learning are both essential fields within artificial intelligence. Machine learning provides the foundation for systems to learn from data, offering transparency and reliability for structured tasks. Deep learning builds on this foundation, using layered neural networks to solve complex problems with high accuracy. Each approach has its strengths and ideal applications, from finance and healthcare to entertainment and robotics. Understanding their differences helps us appreciate the power and potential of AI in shaping our world.